Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at file I/O and specifically how to read the contents of a file. In this case, it'll be numeric. This video is part of a larger series of videos focusing on our files demo and various things that you can do with respect to file input and output. First thing you want to do for this video is we'll presume that you have watched some of the earlier videos on file I/O, particularly our introduction to our files demo, as well as the earlier read demo video. And you want to make sure and grab a copy of your read demo _02.c, as well as a copy of the input 03.txt. You'll see quickly that the input _03.txt is simply a file with a bunch of doubles in there. In this case, what it is, it's values from 0 up to 1. There's a total of 101 values. And what we'd like to do is we'd like to read in the contents of this file, doing some basic file statistics. Now, the idea here is that we are not going to be capturing or storing the contents of this file because, as you're going to discover, is that that may be unnecessary or it may be, if anything, expensive, particularly if there's no sorting involved. In other words, you're going to be using memory, perhaps hard-coded the size of an array, and you may, in fact, not need it. We'll visit this topic multiple times throughout these videos. But what we're going to do is we're going to start first by noticing the background here that I've provided for you. I've provided two links, one for the standard deviation that we're going to ultimately calculate from the data in the file. This is essentially going to require us to read the information twice, but we cannot leverage an array for this particular example, or rather we will not leverage an array for this particular example. And then the second thing that you want to note is a link on the rewind function. And this allows for us to restart or start at the beginning of a file. Once again, a couple of different things in this particular video. Go ahead and copy your function prototypes over. In this case, I'm going to go ahead and include it under my read demo _01. Go ahead and copy the beginning of your function implementation over as well. And you'll note that we once again have a void return value. You can go ahead and close your snips file at this point. And what we want to do is we want to start by setting up reading this file. So the very first thing that you're going to note here is that we are going to need a file input pointer. You might as well go ahead and create a temporary variable that I like to call chunk that will simply store whatever information is pulled out of the file. And then we'd also like to store a couple of other pieces of information. Namely the chunk count, which may be thought of as the number of rows in the file or the number of data points in the file. We also want to capture things like the min value, the max value, and the mean value. And as I pointed out earlier, we would also like to calculate the standard deviation. So in this case, I'm just going to call it standard dev, keep the variable name reasonably short. And what we want to do is think about then the process that we want to follow. The first step, of course, is going to be that we're going to open our input file. So in this case, it's going to be fopen and input _03.txt, and we want to open it for reading. The next thing that we want to do is we want to check to see if our input file pointer is in fact not equal to null, in which case we want to do something. Else, print a message to the user indicates there is a problem. So in this case, error failed to open input file. Once again, we have a void return value. Otherwise, we would probably be setting the results equal to exit failure. And at this point, then what we want to do is, before we forget, we want to go ahead and close our input file. And we want to think now a little bit about initializing some of our variables. And I know this seems a little backwards, but I wanted us to first think about opening the file before we thought about what those initial values should be. Some of them are going to be pretty straightforward. For instance, the chunk count, we will always assume that we have not yet seen any data, so that is simply going to be equal to 0. Likewise, things like the standard deviation, not really that big of a surprise. We'll just simply set that equal to 0.0. And also things like the mean can also be set equal to 0. We probably also could have benefit from having one more temporary variable along with the mean, and that would just simply be the sum that would allow for us then to sum up all the values in order to be able to calculate our mean, so we can initialize that to 0. But then we are left with the min and max. And your first instinct might be to simply set min equal to 0 and the max equal to 0. And that's fine, except for the fact that in certain cases, this could cause problems. Let me give you an example. What if, in fact, you had a file that had negative values? In other words, no value was, in fact, greater than or even equal to 0. So our range might be from -10 to -9. Well, that means that you would have artificially set your max equal to 0 and therefore not have gotten a true maximum value. The same thing can be true for the min. Let's say, for instance, that the values in your file range from +9 to +10, in which case you have initialized your min equal to 0, and you never really see the actual minimum value in your file. Now, there are ways to do this with a flag, in other words, to check to see if this is the first value that you pulled out of the file. But instead, I'd like to do something a little bit more elegant. And that is, before I jump into the while loop that allows for me to read all of the rest of the values in the file, I simply want to read the first value in the file. And to do this, I set up a if statement similar to the one that we saw in our earlier read demo. And that if statement, using an scanf to read the input file pointer and to read out of it, in this case, a %lf, and we are going to store it in our chunk variable. And if that is not equal to end of file, then we can proceed reading the data. And if we do run into a situation where there essentially is no information in the file, in other words, you immediately hit end of file for an error, at this point, then we can decide then how we want to handle this. But at the very least, you can put in a printf that says error, no valid information in the file. And at this point, then we could probably go ahead and initialize these values, min to 0, max equals to 0, or perhaps even some special value that indicated there was a problem. However, at this point now, let's focus on the true branch of our if statement and essentially the trick that we can use to initialize our min and our max values to something other than 0. So at this point, what I'm going to do is I'm actually going to take these two lines out of action here. And instead, what I want to do is I simply want to assign the value of chunk to min, and I want to assign the value of chunk to max. And so while this might seem a little counterintuitive, this guarantees that both the min and the max value at least represent a value in the file. So I'm going to put a little note here. Now we can guarantee that if we have valid data, min and max represent a value found in the file. Now, what about the rest of the values in the file? Well, this is where we can jump now into a while loop. And so at this point, then we're back to our simply looping through all of the elements in the file, or essentially reading all of the values in the file while our fscanf is not equal to end of file. So what we do here is we set up a while loop leveraging our fscanf. If you've not yet had a chance to look at the help for the fscanf function and its sister function scanf, would encourage you to do so. But you'll notice here that EOF is returned if there was an error reading before the first match. So in this case, what we'll do here is while fscanf, and we'll utilize our input file pointer. We will once again utilize a %lf since we're dealing with doubles and store it at the address of our chunk. And if that is not equal to end of file, continue reading. And before we get too far into this, I would suggest that you take just a second to look at what end of file actually means. And it's nothing more than a constant corresponding to the value -1. At this point, then, we can continue reading, but also processing. And what does that mean? Well, our goal is to ultimately capture both the min and the max value, as well as calculate the mean, and then later on our standard deviation. And so to be able to handle the min, we simply say something like, if our current chunk is less than our min, we have a new min. And so in this case, min is going to be equal to chunk. We follow this up with, if the chunk is greater than our max, we have a new max. And so max is going to be equal to chunk. Now let's put some comments here. This means we have a new min, and then we have a new max. Well, so far so good. But we had a couple of other pieces of information that we wanted to capture. Most notably, we were hoping to catch the sum, or capture the sum and the mean, and ultimately use the sum to calculate the mean. But in order to do so, we also needed to be able to keep track of our chunk count. So everywhere that we make a call, or rather a successful call to our fscanf, we simply want to increment our chunk count. And we want to make sure that the current chunk is added to the sum, or in this case, with the first value, we can simply say sum is also equal to chunk. And at this point, then, inside of our loop, we want to do the same thing. Now, does it matter if we do it before or after verifying whether it's a new minimum or maximum value? Does not really matter. We just don't want to forget it. And so we'll first do our chunk count plus plus. But then also what we can do is say sum is equal to sum plus whatever that current chunk is. And by the way, there's also a shorthand notation if you'd like to use it, and that is going to be sum plus equal chunk. Does not really matter. Whichever one you like to use, it's fine with me. However, though, be aware that some of these shorthand notations aren't available in every language. So at this point, we have the capabilities of calculating our mean once we are done reading all of the values in the file. Which brings us then to the exiting of our while loop. In other words, when we are finished with our while loop, what do we in fact want to do? Well, the first thing that we would want to do is to go ahead and calculate our mean utilizing our sum and our chunk count. And at this point then, we have the information to use to calculate our standard deviation. But the problem with it is that if you recall, or if you've seen on the Wikipedia page, you have to have all of the values in order to be able to calculate the standard deviation. Because effectively what we're going to do is we're going to take the square of the difference between the mean value and every value in the file, and then we're ultimately going to sum those up to be able to get first our variance and then our standard deviation, the population standard deviation. So in order to be able to do this, we not only have to reread the file, but we also have to reuse some of our temporary variables. The first problem is going to be handled using the rewind function. And the rewind function then essentially allows for us to go back to the beginning of the file. And so otherwise, what we would have to do is we would have to close the file only to reopen it, and all of the error checking again. Instead, since we still have the file open, why don't we make a call to the rewind function, passing to it our input file pointer. Assuming that there are no issues, in other words, that we've successfully opened the file the first time, then we shouldn't have any problems opening the file or going back to the beginning of our open file. The second thing that we want to do is we want to go ahead and reset our sum back to 0 because we need to leverage that variable for the calculation of our variance, or our sigma squared. And our sigma squared is essentially going to be the average of the sums of the squares of the differences between the mean value and every value in our file. Once again, I encourage you to bookmark that Wikipedia page, but let's get started and see how we're actually going to implement this. So once again, we set up our while loop, we use our fscanf, we use our input file pointer, and we are once again still reading %lf, and we're going to store it in the chunk variable, this time out of convenience, if anything, because otherwise the code will get rather long. In this case, then we'll check to see if our value matches EOF, or rather the return value from fscanf matches EOF. Now, at this point, what I'd like to do is I would like to leverage then the sum variable, and I'll start by essentially aggregating the value by saying sum is equal to sum plus, and then the square using the POW function of the difference between the current chunk and the mean value. So essentially what we're going to do here is we're going to square this, and we're going to add it to the sum. Now, we could also at this point reset our chunk count, but if we assume that we have counted the number of chunks in the file correctly the first time, and there isn't any changes in our file because essentially we have it locked open, we don't also need to keep track of the number of chunks that we have read out of the file. Instead, what we're doing is essentially summing that numerator. Okay, so that is going to be then our numerator for our variance. At this point, once we are done reading the file a second time, then we can go ahead and close it. By the way, I've accidentally inserted this while here above my rewind. I did not mean to do that. This while needs to come after the rewind. Please take a second to fix that. I did not notice that. Must have accidentally clicked in the wrong spot. So we remember that we essentially have to read all of the values in the file once, make our mean calculation, rewind back to the beginning of the file, reset our sum up the squares of the differences, and then ultimately what we want to do is we want to calculate then the standard deviation using the sum divided by the chunk count. And then more importantly, we want to take the square root of all of this. All right, so at this point, it's probably about time to make sure to close our file. And so you can do this immediately after exiting your second while loop prior to your calculation if you wish. At this point, our file is finished. In other words, we don't need it anymore, so we're going to go ahead and close it. And it's probably about time to print out a table. So we'll start off once again with a printf, name, value, followed by a new line. Once again, a nice table border, followed by a new line. And then the values that we have either determined or calculated from our file. And we'll start with some of the basics here. The chunk count, in other words, the number of values, we're going to leave it as chunk count. And that is just going to be %d. We also want to capture or print out rather the min value. That is going to be a %, in this case 0.2f, because we know our format is 2 decimal places. It is going to be the min. We want to follow this up now with the max. Our mean value. And then lastly, our standard deviation. And at this point, let's go ahead and build it. Let's make sure that we have our no errors. So in this case, we have a complaint that says we're using an implicit declaration of the built-in function square root. That's just simply a fancy way of saying that we need to make sure to include our math.h. Let's go ahead and build it one more time. Also likewise with our pow function. And then you'll see that the only thing that we have left to do then would be to update our switches and our help. In this case, what I'll do is I'll add one more switch here, and else if our string compare I are the square brackets 1. And this is going to be our read underscore demo underscore 02. And if that is equal to 0, that means we have a match with whatever the user put on the command line. And we want to call our read demo 2, as well as updating our help. So read demo underscore 02 shows how to read a file with doubles. And at this point, probably the only other thing we want to do is take a second to clean this up. You'll notice that we already have our read 01 demo. It's nice to have them together, although there's no reason for that other than just to simply make your code look nice and neat. We'll go ahead and build it one last time. And we have success. So let's come out to our command window. Let's do dir. You'll see that I have a couple of input files here. However, I do not have the input file that I need, particularly our input underscore 03.txt. The quickest way to get it in the right spot is to open Windows Explorer in the current directory, and we simply copy over the input version 3 to our working directory, in other words, the directory that our executable is in. And then we can run our demo here. In this case, this is going to be our files demo. Check for command line switches. You'll see that our read demo is in fact there, read demo 02. And at this point then, you'll see that there is 101 values in the file, which is exactly what we expected. The minimum value is in fact 0. The maximum value is 1. The mean value is 0.5, and the standard deviation is 0.29. So hopefully you found this video useful. As always, if you have any questions or comments, don't hesitate to ask. And once again, thank you for watching.